Code Organization Without Tears. Okay, it's the title inspired by the classic book, Statistics Without Tears, and it's about higher level code organization. So we're focusing on how we put code into modules and folders rather than functions and classes. And we're not looking at sophisticated naming strategies for folders or implementing a layer architecture, just the mechanics to make internal importing work reliably when you have a nested folder structure. And this is dedicated to a former colleague. Although he is one of the smartest developers and data scientists I've ever worked with, and that's really saying something, he still had trouble getting Python code to work reliably when importing from internal project folders. So obviously something is wrong and internal importing is still too brittle. So I think there's a need for some simple rules that let us do this simple thing with confidence. So code organization without tears. What tears? It's Python, right? We make a simple script. And here is our greet function. It takes a name and just says hi to it. That's all it is. This isn't a trick. And there it is. Just does that. Then we split our code into modules. We pull the greet function into a separate module. I called it help funcs. And then we import that function and call it in our run script. You know that once again, there's no tricks here. That just works. This is the happy path. Our code still runs. Life is good. Python is great. You're probably wondering why this talk. Then you think, maybe folders could make it easier to work with the code. We're not wanting to make an installable package for PyPI or something. We just want to organize our Python modules better. So we do the right thing and we organize everything into folders. And our script stops running. Like they say, no good deed goes unpunished. Perhaps what happened was we decided to split our helper functions into different modules, and we made a new folder, utils, to put them in. And after a minor modification to the import, we tried running our original script again. But instead of this, where it works, we mysteriously get this error here, module not found error. And we think to ourselves, what does it mean saying the module isn't found? We can see it right where it should be. And maybe this is exactly the same structure as we've seen succeed on another occasion or another project, which is really bewildering. Something somewhere must be different, and it's an annoying mystery. The tears. So we've got some options in how we respond to that. One is we retreat. We revert, we abandon, I've seen colleagues do this, abandon code organization. We get pragmatic. We lump all our modules into one monolithic folder and we call it quits. But avoiding subfolders doesn't scale. For simple projects, subfolders can be avoided, but for larger projects, and I see one here, 28,000 modules. But for larger projects, we need proper code organization to cope with the complexity. Folders are good. Embrace folders. Remember, good code organization is not a nice to have. Now, as beginners, we'll start producing spaghetti code, but we soon learn that breaking the code into manageable chunks and organizing those well, naming them well, it makes the code much easier to understand and to maintain. It's the same for modules. We eventually need to organize our code into helpful folders. So here's an example, a pretend reporting library. We've got cleaner names when we put everything into folders. It's no longer jumbled in with completely different modules, so it's much easier navigation. We know exactly where we'd go and what we'd do if we were going to make another sort of chart. So I'm going to reject option 1 of retreating. Code organization is good, so if you need folders, use folders. Option 2, stop mixing scripts and library modules. That's an option. One book I saw suggested that. Maybe the problem is that you can't or you shouldn't really mix scripts and library modules. Where scripts are Python files that do something, you run them, they execute, and library modules are files that only define things. For example, classes, functions, attributes. Note, all Python files are modules, so I refer to library modules and scripts for clarity. So maybe the only solution is to split our code into A, libraries, and B, scripts which import from those libraries. So I've just made a little key there to make it easier. So are there only two contexts for development? Either making single script files or making libraries, which we'll then use with the script. So let's see if splitting into a script and a package of library modules solves our problem. So we do that in practice. We install the non-script parts as a package, for example, into site packages. We then import that package into the script. See there, charmed.utils.main, and it works. And then we run it, everything's good. But is packaging overkill? I mean, potentially, it's sort of simple. This code here actually does successfully make a wheel, but there are lots of options and considerations to weigh up. Python packaging is not easy, or hopefully not yet easy. So we've got poetry, PDM, pyenv, setup.py, wheels, pip with a ---- edit option so that we can keep working on it. We've got all these options and many more as well. Should people, especially beginners, have to think about all of this just so that they can organize their code properly? And even if they do understand all the options, do you really want to do all that work just so that you can use a few library modules from your script? And there's another argument that it's really an abuse of the packaging system, because you're not really making a package for distribution at all. It's simply so that your definitions are separate from the script. So surely there's a better way. There are not just two contexts for development, scripts and library code. We can actually keep the script and its supporting library modules together. There are benefits to doing that in practice. When we run it in our IDE, it's super useful to run them together. Code in the same project is treated better as a first-class citizen when it's compared with external library code, searching all sorts of things. There's the convenience of working right near the code that's being changed. We're less likely to lose context. And it's not just about running the main script. During development, we may want to execute lots of pieces of code inside the library modules, and obviously we need those to run without problems. So it is important that we can get internal importing working in this context. And actually it's the same even if we're doing library development. It is super useful being able to code flexibly within the IDE so that we have to get the internal importing working in that context as well. So I reject that option there of not mixing them. Requiring people to package library modules into proper libraries makes programming cumbersome. It also discourages good code organization. People are deterred. So let's not require that. But fortunately, there is a good alternative as long as we can get internal importing working. So option 3 is to actually try and make this work. Now, being Python, there must be one, and preferably only one, obvious way of doing this, or hopefully, of organizing our library modules into folders and avoiding import errors. That's easier said than done. You Google, you read endless explanations, most of them out of date. You try random solutions from Stack Overflow, and each time you do an experiment, you have a little bit of hope. But it is cruelly snuffed out each time. This is the tears stage. But there is actually an answer. I wish I'd known it a lot earlier. So these are some guidelines for higher level code organization. And these are simple guidelines. There are far too many articles which provide details, but no direction. They tell you lots of stuff, they don't tell you what to do. So we need guidelines, and they need to be simple. We shouldn't require others to have a deep understanding of the mechanics of importing, just so that we can simply organize our code at the very most basic level. Instead, if we follow a few simple rules for internal importing, our reorganized code will just work, and it will work every single time, which is nice. So here are some simple guidelines for high-level code organization. First one is sort of self-evident, I guess. Split your code into modules as needed. It's a prerequisite. We can't have modules in different folders if we don't have multiple modules. it makes it easier to manage the code and to actually think about it. So to start with, we need to break up our giant monolithic scripts. So if we have a mix of helper functions and main logic, maybe we should split into modules that reflect that structure, maybe run.py and utils.py. Notebooks can encourage this problem of monolithic scripts when people shift from that environment into actual coding in modules and scripts. Second thing is to split into folders as needed, but we shouldn't hesitate. So it makes it easier, once again, to manage and think about our code. If your project has a set of modules that all relate to charting, it may make sense to gather them together into a charts subfolder. And it namespaces everything quite nicely, so we can have charts.area rather than area chart and so on. So the goal is that we should be comfortable doing quite radical module reorganization into folders and subfolders and so on without any worries about successful internal importing. So we should be very relaxed about that. So follow the rules relating to importing and running code, and then you can actually put your modules into folders and subfolders with confidence. So here's some more detail now. First one is use absolute importing. In Python, there are two sorts of importing, relative and absolute. So relative importing uses dots, so 1 dot for siblings, 2 for parents, 2 for grandparents, and so on, all relative to the current module. And it does have some advantages because relative importing doesn't use root path names. It can be easier to just make some changes to those names and not worry about impacting the import statements of submodules, although modern IDEs make that easy anyway. And it can be easier to reference sibling modules by just using the single dot. Absolute importing, the other approach, anchors everything to a standard starting point. For example, import charmed.utils.main or import charmed.run. All imports start at the same place. So the advice here is to always use absolute importing in your modules to import other internal modules. If you follow this rule, you only have to think about sys.path to solve any problems. Some more details later. Confusingly, absolute importing is actually relative to the paths in your Python path. It tries them in order. Python path is where Python looks to find where a module lives when we use the module in our code. But you don't have to worry about the details of how that works. You just need a few simple ideas. So let's get some terminology straight so that we can discuss this clearly. Some useful names for things. We need the concept of the main code folder. The main code folder contains all the modules, and it's sometimes called the source folder. We also need a name for the parent folder of the code folder so we can refer to it when we're talking about Python paths later. Perhaps we can call it the surrounding folder. It's sometimes called the repo folder. It's often your project folder, but not always. People structure things in different ways. A project folder is the logical place to store both your code under the code folder and also any non-code files associated with your project. For example, requirements.txt, setup.py, project docs. Now we can have more than one level of subfolder if we need it. Here we've just got one in this example. So in this demo project Charmed, got some files there. That's as it might appear in an IDE. And a clear folder structure makes it easier to navigate to code you need to work with, for example, adding a new type of chart. Okay, that's the project folder in this example. It's also the surrounding folder, and it commonly has the same name as the code folder, which can be confusing at first, but that's pretty conventional or widespread anyway. This is the main code folder in this example. All absolute imports in our code are anchored to this folder. So that's the surrounding folder, that's the main code folder. If run.py needs to refer to py.py, it can use the following absolute import. We always start here at the anchor. So import charms.charts.py. Or if we want to refer to main.py, we start in the same place, utils.utils.main, and that will take us to the right place and it will work. So we always need to include the main code folder in our import. That's our anchor, not the surrounding folder, the code folder with anything else we need. We don't leave it out and just have this a subfolder or the module itself. That won't work, or not reliably. We must have the anchor. Another good piece of advice is not to do random crazy stuff. If you had this problem, and I don't know how many of you will have, you can get pretty desperate. And desperate coders do desperate things, but don't apply random solutions from Stack Overflow. Don't add empty dunder-init files everywhere. I'm not saying there's anything wrong with dunder-init files. They're useful for other purposes, but that's not your problem, or probably not. It won't help. They haven't been required for this purpose since Python 3.3, but they are required by things like, I think, PyTest, setup.py, and other tools. But this isn't what you do to solve the problem. You might be tempted to swap back and forth between relative and absolute import. Some of this might just be autobiographical. And if absolute importing isn't working, relative importing almost certainly won't. Don't hack sys.path. I mean, it may make the code run, but you may need to repeat that in different modules. It's hard to maintain, and there's a better way. Don't hack dunder package. You have to be really, really quite desperate to even think about doing this. Maybe you've gone down a rabbit hole on the internet looking into things, and don't think maybe ChatGPT can save me. There are no words for how desperate you must be if that's what you're now doing. So doing crazy random hacks from Stack Overflow is like drinking seawater to quench thirst. It seems like a good idea, but it usually ends badly. And this is a cruel reality. I thought I'd get the skull saying this, that cruft from your earlier solutions can sometimes break your code, even though you've actually gone and now fixed the original problems. And so it's still broken, and then you finally go to bed at 1 a.m. exhausted and defeated. So don't do that. Run your code in one of the ways that actually works. I know that's a crazy idea, i.e. one that puts the surrounding folder in sys.path and handles module files properly. So just a refresher, if you're running a single script, there's no internal importing. There's no other modules internally to import from. You just run it in your IDE as a script. You might press a run button or F5 or Shift F10, etc., depending on your IDE. Or you're running it from the command line. You might change into the script folder and run Python 3 run.py. That works. Or you might, instead of changing the path, you include it in the command, and that also works. You can see why people sometimes stick with single file scripts, even big ones, because they know how to make it work and it doesn't break. So it's nice and simple. And now if we're running a script in a single folder and we've just got some sibling modules. So if we do the internal importing by name only, no dots, no anything else, just the name, help funcs in this case, then the simple Python 3 file name approach, that it'll work just like before, like for a single script, Python 3 run.py, and it'll work. Other approaches can be made to work. I can't remember what they are even now. I researched them, but you should just keep it simple and not use the dots. So now we're thinking about running code organized into folders. We can't use the Python 3 run.py approach anymore. Python won't understand the module nesting, and you get things like module not found error, no module named charmed, which is pretty depressing when you encounter that, when you know there is one. So you run your code using -m, one of these mysterious options from the command line. So you might change directory into the surrounding folder. It might be the project folder if you have one, but it's the surrounding folder that is what matters. And then you might run something like Python 3 -m and the package name .myscript, and that will work. Note, this is not a file reference using a path, so we don't have .py at the end. That's another little thing that can go wrong. It's just a module. And what happens when we use -m, and I looked it up in the doc, because I didn't really exactly know, except that it sort of worked. It finds your code in the module system, and then it runs it like a script as having dunder name equals dunder main. So there you are. That's officially what it does, but it works. Now, if you're using an IDE as opposed to working from the command line, you may be able to add the surrounding folder, the Python path for your project. Now, this is very IDE specific, but here's a couple of examples, although it was surprisingly challenging to figure it out. Okay, so this is PyCharm. I went into configurations, and down the bottom, I ensure that that's actually ticked where add content routes to Python path. And that will work assuming that your content routes include the surrounding folder. If that's the case, then you're in business. And the content routes are actually set under file settings. So if you created the project from the surrounding folder, you might go right click and create project, then this will already be what you need, the surrounding folder. Just again to remind you, the surrounding folder, the code folder. You want the surrounding folder. If you're using idle, which is a good standby, I use it all the time for small things, you open it from the surrounding folder. So you change to that, open idle from there, and then success, the surrounding folder is in the path, everything just works. So just a refresher on that, single script, no internal imports, you just do the Python and run thing. Works the same way, not a big change when you're dealing with where all your modules are in the same folder. It's a big jump in the number of things that can go wrong and the number of things you potentially need to understand. But if you do absolute importing from the code folder, like charms.utils.main, and you run it like from the surrounding folder, like python 3 -m charmed.run, then it'll work. Okay, troubleshooting. Spoiler, you probably need to go and check and correct sys.path. That's probably what it is. And it can seem daunting. It all depends on how you're running Python. I don't know, how many people have seen this cartoon before? Yeah, a number of you have. It's a depressing cartoon. It's funny. And it's probably, I don't know, is it worse than that now? But anyway, there's a lot of ways you can run Python. But it's fundamentally simple. The good news is it's fundamentally simple. If you have import problems when you're running code as a script, first thing to do is check for typos. Now, if you are getting a bit distressed and tired, if you've been trying all these Stack Overflow solutions and things, by now, you might not even be able to see what's in front of your own eyes. But often it's just a simple typo or some other basic mistake. Then check that your absolute importing starts with the code folder, not the surrounding folder or a subfolder. It's the one that contains the code. Ensure the surrounding folder, usually the project folder, is in sys.path. And if there's a problem, it's usually that. And if you can't run your module as a script, check your Python path. So in the standard example, it would be this folder. We'd need to see in sys.path, not the charmed folder, which is the code folder. By the way, these slides, I presume, are available or something. How to check your Python path. If you have a problem and you look at your Python path, you're likely to see that the surrounding folder is not actually there. So just look. And to look at the Python path that is actually being used in the version of Python that is running your script that is having the problem, you need to see sys.path. And a really simple way of doing that is to add the following line to the module that raised the exception. Import sys, semicolon, so it's a one-liner, print sys.path. And then you'll actually see, is it there or not? And you'll have your answer. Make sure you add this line. This is an obvious point, but you can get a bit stressed when this sort of thing happens. Before the import line, otherwise it'll never run and you won't see the output. Okay, so here's a PyCharm example. What happened here was I made a project on purpose from the code folder. I right-clicked on the code folder instead of the surrounding folder and said, make me a project. And I didn't ensure that the surrounding folder wasn't sys.path. Easy thing to do. You wouldn't even notice that you'd done it differently from last time, the time that worked, and now it's not working. So if you created the project from the code folder down there, that content route will not be what you need. There's some other possible solutions. I'm not going to go through those now. It's very IDE specific, but you can go into some pretty dark places. I'd recommend instead just creating your project from the surrounding folder and it'll just work. So, summary. Split your code into modules as needed. Organize those modules into folders as needed. Use absolute importing. Always start absolute importing with the main code folder. Don't do random stuff to get broken code working. And instead, run your code in one of the ways that actually works, i.e. that puts the surrounding folder in sys.path and handles module files properly. I won't go through this one again, but it just shows you the different sorts of things you're doing and how to successfully and reliably and 100% succeed. And the guaranteed result is code organization without tears. That's it.